The first person I'd like to introduce you to is Dr. Dan McCleese, who is the chief scientist here for the Jet Propulsion Laboratory.
Thank you, Diane. This is a real thrill for us at JPL to have you here. We are very much interested at JPL in sustainability. I think the Beyond Waste theme is a very exciting one, and I want to extend a special welcome to our finalists among the innovators who are participating in launch and in the activities of the next couple of days. There's a lot I could say about JPL. We're fairly well known in the space business and across the nation, and I want to give you a couple of themes. One is that JPL is the nation's gateway to the planets. I'll talk a little bit about one planet we're visiting. I want to tell you that we do a substantial amount of the observations of weather and climate on Earth, and we have experiments that are looking to understand more about the cosmos, extending from the Earth out to the edges of the known universe. And all of these are done through the application of technology and science, the kinds of themes that you will hear from NASA centers all over the country. Our focus, as I said, is we are the center, the NASA Center for Planetary Exploration. There's a lot going on at JPL at any given time, but you are here at one of the most special times that we have at JPL, and that is the landing on Mars, which is coming up. So I just want to tell you a little bit about that. And we are landing a vehicle called Curiosity, the Mars Science Laboratory, on the surface of Mars 16 days from today. This is a rover that is about the size of a Mini Cooper, so it would be substantial sitting here. It is a mobile laboratory. It's carrying the kind of equipment on board and within it that geologists, chemists, biologists use in their laboratories when they go out into the field and collect rocks, bring them back, try to understand the history of the region of the Earth. We're trying to understand the habitability, the history over time of the development of the environment, climate we call the Mars environment. And so this is the vehicle that will be landing on the 5th at 10:30 p.m. Pacific time. It's an event you won't want to miss. You can go on the NASA website, JPL website. A lot of cable networks will be carrying it, but I suggest you have a look. And I'll give you a reason for looking in just a moment. So we're going to be entering the atmosphere of Mars on the 5th. We are going to be screaming into the atmosphere at about 13,000 kilometers per second. We'll be going about the rate at which you would see a fireball entering the atmosphere. It's got to go from a speed that is that high to 0 in about 7 minutes. We're going to a site on the planet, which is a place that's called Gale Crater, named after an astronomer who studied the surface of Mars. This is a particularly important location on Mars because we believe that it is the accumulation inside a crater of a mound of material that's been deposited over the last several billion years on the surface of Mars. And that mound records the history of the evolution of the planet. Climatically, surface changes, the way in which the modern environment has impacted the past record, all of that is going to be seen in layers that are going to be traversed by this rover. And when the rover lands, it will spend time getting itself oriented, accepting instructions from the Earth, and then it will begin both a guided and autonomous activity on the surface to collect rocks, to process them, and to analyze them. And down here in a little corner, you may be able to see the traverse that we're going to be taking up the side of this mountain doing the observations that look at this, if you like, library in geology, a stack of layers that record, as does the Grand Canyon for Earth, a period on Mars history where we think at the earliest times there may have been substantial water on Mars and maybe the environment suitable for life. So I'd like to run a video for you, which we call the 7 Minutes of Terror. It's our terror of the entry to landing of the Curiosity rover. And everything that you're going to be seeing is automatically done. The light time from Mars to Earth makes it impossible to control what's going on. And so you're seeing an automated activity, and I think you'll enjoy this, and it'll bring you to the evening of the 5th and give you some sense of what exciting things you're likely to hear about and see. So could I have the video, please?
When people look at it looks crazy. That's a very natural thing. Sometimes when we look at it, it looks crazy. It is the result of reasoned engineering thought, but it still looks crazy. From the top of the atmosphere down to the surface, it takes us 7 minutes. It takes 14 minutes or so for the signal from the spacecraft to make it to Earth. That's how far Mars is away from us. So when we first get word that we've touched the top of the atmosphere, the vehicle has been alive or dead on the surface for at least 7 minutes.
Entry, descent, and landing, also known as EDL, is referred to as the 7 minutes of terror because we've got literally 7 minutes to get from the top of the atmosphere to the surface of Mars, going from 13,000 miles an hour to 0 in perfect sequence, perfect choreography, perfect timing, and the computer has to do it all by itself with no help from the ground. If any one thing doesn't work just right, it's game over.
We slam into the atmosphere and develop so much aerodynamic drag. Our heat shield, it heats up and it glows like the surface of the sun. 1,600 degrees.
During entry, the vehicle is not only slowing down violently through the atmosphere, but also we are guiding it like an airplane to be able to land in a very narrow, constrained space. This is one of the biggest challenges that we're facing, and one that we had never attempted on Mars.
Mars is actually really hard to slow down because it has just enough atmosphere that you have to deal with it. Otherwise, it will destroy your spacecraft. On the other hand, it doesn't have enough atmosphere to finish the job. We're still going about 1,000 miles an hour. So at that point, we use a parachute.
The parachute is the largest and strongest supersonic parachute that we've ever built to date. It has to be able to withstand 65,000 pounds of force, even though the parachute itself only weighs about 100 pounds.
When it opens up that fast, it's a neck-snapping 9 Gs.
At that point, we have to get that heat shield off. It's like a big lens cap blocking our view of the ground to the radar. The radar has to take just the right altitude and velocity measurements at just the right time, or the rest of the landing sequence won't work.
This big, huge parachute that we've got, it'll only slow us down to about 200 miles an hour. And that's not slow enough to land. So we have no choice, but we've got to cut it off and then come down in rockets. Once we turn those rocket motors on, if we don't do something, we're just going to smack right back into the parachute. So the first thing we do is make this really radical divert maneuver. We fly off to the side.
Diverting away from the parachute, killing our horizontal velocity and our vertical velocity, getting the rover moving straight up and down so it can look at the surface with its radar and see where we're going to land. And we head straight down to the bottom of a crater, right beside a 6-kilometer high mountain.
We can't get those rocket engines too close to the ground. because if we were to descend propulsively with our engines all the way to the ground, we would essentially create this massive dust cloud. That dust cloud could then go and land on the rover. It could damage mechanisms and it could damage instruments. So the way we solve that problem is by using the sky crane maneuver.
20 meters above the surface, we have to lower the rover below us on a tether that's 21 feet long and then gently deposit it on its wheels on the surface.
As the rover touches down and is now on the ground, the descent stage is in a collision course with the rover. We must cut the bridle immediately and fly the descent stage to a safe distance from the rover.
So have a look. I think you'll understand from this last part of the descent why at the beginning, you'll think this is crazy, the guy says, right? The engineer is saying, you'll think, but really a lot of engineering has gone into this and it makes a lot of sense. But if you see people wandering around the lab the next couple of days looking worried, well, there you go. So welcome to JPL. I hope you have a fabulous meeting and I'm excited to hear some of the results. Thank you.